Okay, so let's start with exercise 1.5. In exercise 1.5, we have two types of ODEs. One is linear and one is non-linear. In exam, we might get the definition of what is a linear ODE. So what is a linear ODE? A linear ODE is mostly represented in this type of equation: y dash plus p of xy is equal to q of x. Okay, so this is one way of representing it. I'm just gonna write it over here. It can be represented as y dash plus p of x y is equal to q of x here. Or it can be also this one. In this equation, the dependent variable is y. But this equation can also come in another form, in which the dependent variable might be x, which could be written as dx by dy, or just x dash is e plus p of y x is equal to q of y. In this one, the dependent variable is x, so it can be expressed like this too. So what does it mean to be a linear ODE? So a linear differential equation is one where the dependent variable, which in case is y, have a degree of 1. Okay, so the degree of the dependent variable and the differential forms, like suppose we have y dash, y double dash, and so on. All of these must have a degree of 1 if they are present in the equation. Okay, and these cannot be multiplied with any sort of transcendental functions. Transcendental functions means stuff like trigonometry, logarithm, exponential, hyperbolic, and stuff like that. These should not be multiplied to any of that, and these should not be in product form with each other either. Okay, so that is a way we can identify whether or not our equation is linear or not. I have some examples. So look at over here. In here we can see that these are actually non-linear ODEs. Here we can see that y has been multiplied with another term, another form of y, which is like y dash, and they have been multiplied. So this is they form a product, which should not be like that. So this is a non-linear ODE. In this one, as you can see, this is y dash plus y. This is fine, but in over here we see a trigonometric term, which is a transcendental function, which and the y has been written in terms of a trigonometric function. So this is also non-linear. In this one we can see y dash plus y square is equal to x, and here the degree of y is 2. So that's why this is also a non-linear ODE. Here are some more examples. This one, as you can see, y double dash x square plus y xy into y dash. The dependent variable, which in this case is y, can be multiplied with stuff like with other variables like x or x, but it cannot be multiplied with itself. So in this one, this term is fine, this term is fine, and this is also fine, because here the trigonometric term is in terms of x. So this is linear. But over here, as you can see, the y dash term has a degree of 3, which should not be there. So this is a non-linear functions. Similarly, this one is power 2, which is again a degree of 2, so non-linear. over here there is a product of the term y terms, so this is non-linear, and here we have a trigonometric function of sine y, so phi, so this is again non-linear. Alright, so I think that makes it clear what non-linear functions are. Now let's proceed with some of the questions. These ones are non-linear functions, so these ones are linear functions and these ones are non-linear. I have attached the formulas over here too. So to solve a linear ODE, well, to solve a linear ODE, what we have to do is, suppose this is our equation p of x y is equal to q of x. So this is our linear equation. Now the p term which is given over here, we have to find an integrating factor in this too. So first of all, we will be finding the integrating factor, which is equal to e to the power p dx or dy, depending on which is the dependent variable. Here it is of course y, so this is going to be integrated in terms of x, because p is in terms of x. So whatever is multiplied to the y term in the equation is the p, which is p, and we use it to find the integrating factor. So from here the integrating factor comes out, and then to proceed after that, we ignore this term, and then we just go further, like the y is multiplied with, this is also ignored, this whole term is ignored, only this y is taken, which is multiplied with if, which is taken is equal to integration of q of x with basically the q term could be any function of x, or it could be a constant. It is good either way, so it could be q of x, and this is going to be multiplied with if too, and this is how we obtain our answer. So let's just see question number, we are going to start with question number 3. So in the third question, we have y dash minus y is equal to 5.2. okay, so as you can see over here, so this is indeed in the form of a linear ODE. So our p term over here is actually minus 1, as you can see from here, right? That y is basically multiplied to minus 1, so whatever is multiplied to y is taken as p. Here it is minus 1, so we're going to take p as minus 1. Now we are going to proceed to find the if, basically the integrating factor. So if, which is the integrating factor. Now we're going to find that one. So the formula of it, which I had told before, is if is equal to e to the power p dx. Here our p is equal to minus 1, so we're gonna write it as e to the power minus dx, minus 1 dx. So this is going to come out as e to the power minus x. Alright, so this is our integrating factor in this question. if is equal to e to the power minus x. Now what we are going to do is we are going to multiply the if with y, only y, nothing else, just y is equal to, so if in the question there is a term attached over here, so make sure to remove it by dividing the whole equation by that term, so that it only stays like this. Okay, So if multiplied by y is equal to integration of what is a q. A q is a constant over here, which is 5.2. 5.2 multiplied by e to the power x minus x, I mean, which is also our if. I'm just gonna write the if over here. So our if is equal to e to the power minus x into y is equal to q is equal to 5.2, and this is going to be e to the power minus x. When we solve this, we get y e to the power minus x is equal to minus of 5.2 e to the power minus x, and this term gets cancelled out, so y is going to be equal to plus c. Of course, do not forget the plus c. So y is equal to minus 5.2 plus c, and here is our final answer of the third question. Now let's see the sixth question. Here is the sixth question. Let's solve that. Sixth question, let's solve that. So the question is given as y dash plus 2y is equal to 4 cos 2x with an initial value, or we have also provided with an initial value in this question, so which is 1.4 pi is equal to 3. So as you can see, the p in this question is 2. So we can write p is equal to 2, which means our integrating factor will be equal to e to the power 2 dx. It is equal to e to the power 2x. Now we're going to multiply it. So e to the power 2x into y is equal to, what is a q over here? It is 4 cos 2x. So we're going to multiply it with that. So 4 cos 2x e to the power 2x dx e power 2x into y is equal to, we are going to take 4 out because it's constant, cos 2x e to the power 2x dx. Now to solve this, we are going to be using by parts. It's quite clear. So let's just take I is equal to integration of e of 2x cos 2x. Now using by parts, we get cos 2x e to the power 2x minus bracket minus 2 sine 2x e to the power 2x dx. So this can be written as cos 2x e to the power 2x by 2 plus sine 2x e to the power 2x dx. Now we have to use by parts again on this term, so let's just do that. It is a lengthy equation. So cos 2x by 2 e to the power 2x plus sine 2x e power 2x by 2 minus 2 cos 2x e to the power 2x by 2 dx. Now we can see that this term is basically, the 2 of course cancels out, so this term is basically the I term, this term. So we're going to write it like that, and this whole term is cos 2x by 2 e to the power x plus sine 2x ex by 2 minus I. This whole term is equal to I, which is, well, this, because like we of course we biparted this, so this is equal to I. And then proceeding further, if we take I to this side, this is going to, let's just write it down. So cos 2x e to the power 2x, the 2x over here, 2x by 2 plus sine 2 e to the 2x e to the power 2x by 2 is equal to 2I, which now if we write it in terms of I, it can be written as I is equal to 1 by 2 cos 2x by 2 e to the power 2x plus sine x e to the power 2x by 2. Now let's just, now that we have finally gotten our IF, we are going to proceed with the final solution, which is we are going to proceed after this part now. So for the solution, it's going to be y into e to the power 2x is equal to 4 by 2 cos 2x e to the power 2x by 2 plus sine 2x e to the power 2x by 2. Well, this cancels out, and if we take 1 by 2 common, we get, if we this cancels out, it leaves us with a 2, and then if we take 1 by 2 common from these two, this also cancels out, so we are left with y into e to the power 2x is equal to e to the power 2x cos 2x plus sine 2x. And if we take a if we take ln both side, if we take log on both side, we get y is equal to cos 2x plus sine 2x plus c. Now the initial value problem which was given to us was y of pi by 4 is equal to 3. From here we can get that x should be put as pi by 4. So let's just do that. So this is going to be written as 3 is equal to cos 2 pi by 2 pi by 4 plus sine 2 pi by 4 plus c. So these two basically just turned into pi by 2. this turns into pi by 2, and as we know cos 90 is 0, sin 90 is 1, so the equation is 3 is equal to 1 plus c. From where we can get c is equal to 2, and this will be our answer for question number 6. Now let's proceed with some non-linear ODEs. So let's try with question number 23. So as we know what non-linear ODEs are, as you can see, all of these ODEs are indeed non-linear with the way they have been presented. Like for example, in this one, the degree of y is 2. This is non-linear. Here it is the degree of y is -1. Okay, so this is also non-linear. So how do you solve a non-linear equation, non-linear ODE? Non-linear ODE. Well, let's see. In non-linear ODEs, our equation is given in this form. As you must have noticed in the questions, it was indeed given in this form. And over here, a term of y, y might be multiplied with the q, and it is not necessary, but it might be multiplied. So what we have to do is divide the whole equation by the term q has been multiplied to. Okay, so then after we do that, after doing that, we have to take whatever is being multiplied with the p term. This was the p term, and then we divided the whole term by whatever was multiplied to the q, and then we have to see what do we obtain, and then whatever has been multiplied with p, we have to take that and then put it as v, and then we have to differentiate it once. From there we will get the v dash, and then from there our equation turns into a linear equation in terms of v. So from there we just proceed like we did previously. We substitute the values, and then we find out the integrating factor and then solve it like we did. So let's try a let's just try question number 23. So question number 23, the question is given as y dash plus xy is equal to xy minus 1. So, and we are also given with an initial value which is y of 0 is equal to 3. So as it had said, first of all we have to divide the whole term by whatever has been multiplied with q. This is our q. So whatever has been multiplied with q, we have to divide the whole term by it. So dividing by y minus 1, we get y dash y plus x y square is equal to x. From there, after that we have to put whatever has been multiplied to p as v. So in this whole thing, our p is this. So this is our p. So whatever has been multiplied to p, so this has been multiplied to p, we will take this as v, and then we will differentiate it once. So we will get 2y y dash is equal to v dash. From here we can also write y dash is equal to v dash by 2. Now substituting it in the equation, we get 1 by 2 v dash plus xv is equal to x. Now as you can see, this has turned into a linear equation. Let me just divide the whole term by 1 by 2 so as to like make it more solvable. So this will be like this. Now let's just find out the integrating factor, which is going to be e to the power, here p is 2x, so the integrating factor will be e to the power 2x dx, which will be equal to e to the power x square. Now writing it like we did, and previously there used to be y over here, so we used to multiply the if to y, but here we have v, so we will be multiplying it with v. So this will be e x square into v is equal to e to the power x square 2x dx. Now let's take x square is equal to t, so that it is easier for us to solve, and then 2x dx will be is equal to dt. Now substituting these values in the integration, we get e of t into v is equal to e of t dt. From there we get e of t, v is equal to e of t plus c, and then v is equal to e of t cancels out over here, so this will be 1. The whole term was divided by e of t, so this is how it's going to be written. Now we are going to substitute the values back in. So what was v? So v was y square, so y square is equal to 1 plus c, and substituting the value, this is x square. Now for the initial value, which was given as y of 0 is equal to 3, this can be written as y is equal to under root of 1 plus c e to the power x square. So putting x is equal to 0, we get so y will be is equal to 1 plus, so, and the value of y was given as 3, right? So 3 is equal to 1 plus c, squaring both sides we get 9 is equal to 1 plus c, so c will be is equal to 8, and this is our final answer for equation for question number 23. Let's try question number 28 as well. Question number 28. So the question is given as 2x y dash, where is it, right? In this question, as you can see, there is no y term that has been multiplied to this part to q, so we're just gonna assume it as 1, and if we divide the whole thing as by 1, it makes no change. Here we are, however, said that to put y square is equal to z, so we can assume that the y term that is supposed to be multiplied with q was already divided by the whole term for us. So this is our p, and this is what we are going to be taking as a new variable so as to make this whole equation linear. So let's just do this. Plus x minus 1 y square is equal to x square x square e to the power x. Y of y square, we are going to put it as z. So 2y dash is going to be z dash. So substituting the values, we get z dash x plus x minus 1 z is equal to x square e to the power x. Now we got to divide the whole term by x because there is an extra x over here, so we're just going to do that. So this is going to be x minus 1 divided by x z is equal to x square e of x. Now here our p is going to be x minus 1 by x, which can be written as 1 minus 1 by x. So integrating, we get 1 by x dx. This can be written as e to the power 1 dx minus dx by x, which can be further written as e to the power x minus e to the power ln x. By the property of logarithm, we can write this as e to the power x into e to the power ln x minus 1. So this can finally be written as x, it's as e to the power x minus 1, which can be written as e to the power x 1 by x. So this is our if, our integrating factor. So now we are going to multiply it to the terms. So from there we will get e to the power x by x into z is equal to e to the power x by x into ex. We got this dx. So this turns out to be e to the power x z is equal to e to the power 2 x dx. Now integrating this, we get e to the power x by x z is equal to e to the power 2x by 2 plus c, and then we get e to the power x by x y square. We are substituting back the values, and then y square is equal to e to the power 2x by 2 plus c, and this will be our final answer. And this is how you solve a non-linear ODE. So that would be it for this one. There are also some modeling questions in 1.52, but they will be covered in the